No, you have to.
So in this problem, we are going to test the mean dive duration of North Atlantic roads. The mean is equal to 11.5 minutes. That is the claim that the dive duration, average dive duration of North Atlantic whales is 11.5 minutes. Where should that statement go? Should we write it here or there? Why in this?
Because that's normal.
Because it has an equal sign. So if this is mu equals 11.5, what is that? Not equal to. So where is the claim? The claim is in the north. So that is our claim. Mean is 12.2 minus mu naught. Do we have mu naught? Yes, 11.5 divided by standard deviation.
I have a question.
Yes.
What if your null hypothesis isn't mu equals? Then do you not have a null? Or is it going to be that every time?
No, in the previous problem, we had mu greater than or equal to. In the problem before, we had mu greater than or equal to, right? The mu would always have the equal sign.
Okay.
Even if I say greater than or equal to, there is.
So you can still use that as if it was just this.
What is the value of the test statistic?
1.8553.
1.855. Oh, rounded right, that's 1.86. Where does the test statistic? Oh, excuse me. What type of test is this?
Two-tailed.
This is a two-tailed test. So the rejection region has to be on which side?
Left and right.
Left as well as right. So what is the area on either side of the center? So the key difference between this test and the last two tests is that those are one-sided tests, either the right side or the left side. Maximum error is alpha. Here, the maximum error is still alpha, but I have two sides, so I have to divide the alpha by 2. So 0.1 divided by 2, 0.05. How do we find this critical value? Again, inverse T. So T sub in this case 0.05. N minus 1 is 33. Is it necessary to find both of them?
No.
No. If you find one, you can multiply by -1 to get the other. So what is that equal to?
-1.69.
So if this value is -1.69, this is positive 1.69. Yes? So the interval in orange on the real number line is my rejection region, and I've got two of them, one on the right, one on the left. Where does the test statistic fall?
On the right.
1.86 falls right here. So we will have to reject the null.
Because it's less than 0.1, right?
Because it's.
No,
the
because
rejection
the
zone.
test statistic falls in the rejection region. We haven't gotten to that part yet.
Oh,
So we reject the null. So if we reject the null, we're going to go with the alternative. So here is my question. Do we have enough evidence to support the claim?
No.
No. We have evidence to go against the claim, right? So the data is telling us to go toward the alternative. So there is not enough evidence. To support the claim. So
Do we put that we don't have enough evidence to support it, or that we have enough to go against it?
Wouldn't you say evidence goes against our claims?
So we can say enough evidence to go against the claim,
Okay, or
or
not.
not enough evidence to support the claim. Right? It's either way, it's semantics, but as long as you get the point.
Okay, I didn't know if you needed.
So I would start with, the simple case, reject null, which means that's gone, so the claim is false. But semantically, we can't say claim is false. The proper way is to explain it in this manner. So I would start here and build up from there. Okay. Alex, did you have a question?
It was with respect to the p-value, but I guess you're gonna do it right now, so.
I'm about to do it.
Yeah.
So we already had the conclusion using the critical value approach.
You did already get the p-value.
I tried.
What did you get? 0.03.
So in this case, since we have two tails, and this is a two-tailed test, the p-value is 2 times
And that's
the area above the absolute value.
I was thinking equal to 2 values.
Maybe I'm wrong, but I think that's right. And I got less than 0.5 or something like this.
Well, no, 'cause it's-
Of the test statistic. Now you may ask me, well, where does this 2 times come from? Well, we've got right hand side, we've got the left hand side. I'm going to find the area on one side, multiply it by 2, because it's a 2-tailed test. So,
Quick question.
yes,
Can't you just find the area to one side and compare it to alpha over 2?
you can.
Another quick question. It's 0.05.
You waited all this time and get 0.05.
Yeah.
Okay, so the area about the absolute value of the test statistic. Absolute, important, the 2, important when it comes to a 2-tailed test. We already have a positive test statistic, yes.
So if we get a negative test statistic, we just use a positive value and calculate the area to the right.
Yes.
Okay.
So we already have a positive test statistic, so absolute value doesn't matter. But if we have a negative test statistic, we have to take the absolute value. So we start at 1.86, and it is the area above. So 2 times, we found the area using TCD. Where should we start? Area above the absolute value of test statistic. In this case, that is 1.86. We end at E99, and what goes next?
Degrees of freedom,
degrees of freedom, and what is that?
33.
And what do we get?
The TCDF part is 0.0359.
But then don't check the variable part of it too. So we 0.0718.
So 0.0718 is 7% less than 10%.
Yes.
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 0.1 alpha simply means 10%. The p-value is 7.18%. Since the p-value is less than alpha, which is 0.1 given in the problem, we reject the norm.
For some reason.
The conclusion will be the same. The interpretation, the maximum probability of error that we were willing to tolerate was 10% in the test. But based on the current evidence, it turns out that that probability is only about 7.18%. I personally would think even 7.18% is a bit too high.
You think so?
I'm thinking
So what would it be under 5%?
under 5% reasonable, yes.
So in other words, with the p-value, the scale test, just the absolute value of alpha.
Absolute value of the test is
Oh, it's okay. Or, yeah.